All right, the last section in chapter 4, 4.8. This brings back a lot of our SOHCAHTOA rules. There's really not a lot of new skills going on, just some new directions. All right, so this will just take us one day to get through. Solving a right triangle means finding all the missing lengths and all the missing angles. Basically what that means, okay? So we're going to use sine, cosine, and tangent. We don't really need the reciprocal functions to help us figure this out. All right, so here's the directions for the next problems. This should be labeled directions, so feel free to write that in if you want. Solve the right triangle shown in the figure. Round lengths to 2 decimal places and express angles to the nearest degree. Okay, sometimes we use decimals for angles too. So that's what the authors asked us to do in the OTI anyways. So this one already is in a decimal form. All right, so I don't want to mess with this diagram. I'm going to draw a new one right here. So let's go ahead and just create a right triangle. All right, it's pretty routine to do this. You may remember this from geometry. The angles, they use capital letters, and then the side opposites those are going to be lowercase of the same letter, okay? So if we're going to put angle A right here is 23.5 degrees, I guess I have the option. I could put it in either one of these spots. I'm going to put it right here. Then automatically, side A has to be right across from it. Okay, so A has to be here now. All right, so B, I'm going to make this the other leg because C is going to be the hypotenuse every time, okay? Back to Pythagorean's theorem. So if I put lowercase b here, then angle B must be across from that. Okay. Angle C is obviously 90 degrees because it's a right triangle, and side C, lowercase c, needs to be here. Okay, so to solve the triangle, we just got to start piecing this together. You can actually start this a couple different ways. Probably the easiest thing to find right now will be angle B. Angle B is going to be equal to, we know the sum of a triangle adds up to 180, or even a shortcut ways, this is, since 90 is already out of the way, these two add up to 90. All right, so to get this one, 180 minus these two, or 90, I'm going to do the shortcut, more efficient way, 90 minus 23.5. So that gives me 66.5 degrees. I'm going to leave it in decimal form, even though the direction said nearest degree for now, because your textbook will ask you to keep it in decimals. Okay, now from here, I need to find side A and C. That's what I'm missing right now, right? All three angles are accounted for, and to solve the triangle, I need to find all the unknowns. So let's go with A. How can I find A using the skills we've been working on in chapter 4? Okay, well, this is the opposite side of this angle, and we have the adjacent side. So I can use that to my advantage to set up a tangent relationship. Okay, so tangent of angle A, 23.5 degrees, equals side A over 12. All right, we did this in section, I want to say 4.4. We did a lot of the SOHCAHTOA rules, maybe 4.3. Okay, all right. And now we need to solve for side A. I like to cross multiply here because the cross multiplying works if A is on top or bottom. So if I put this over 1 and just cross multiply it to get it out of fraction form, it gives me this. A times 1, 12 times tan, 23.5 degrees. And now it's ready for the calculator. Now, I just said the word 23.5 degrees. We have to make sure we're not in radians mode, and we are sometimes in these calculators from our graphs, which here's an example of a graph that's in radians mode. So you got to go back to mode and get back in degrees. Okay. All right, and then I just punch in what I see. 12, 10, 23.5, and I get about 5.2 to the nearest. They said 2 2 decimal places, so that 7 forces that up to a 2. So A is approximately 5.22. All right, now to find C, it's kind of up to you. I've got options. We could use Pythagorean's theorem. I like to review trig because this is a trig class. So I'm going to find C using trig. I could also throw an angle B and use that to find C. So you've got options. I'm going to go ahead and stick with this same angle, and I'm going to stick with 12 since it's an integer. So if I'm given adjacent and I want to find the hypotenuse, you got to ask yourself which of our trig functions from SOHCAHTOA deals with A and H, and it's cosine. Remember the SOHCAHTOA if you want to write that down somewhere. Just a quick reminder of our 3 main trig functions here with right triangle trig. Okay, so as I mentioned, we're looking for the hypotenuse right now, and I'm given the adjacent side. And that's the only one of these 3 that deals with adjacent hypotenuse. So I'm going to set up a cosine relationship now. Okay, so cosine of 23.5 degrees equals 12 over C. Okay, now it's in the denominator, but like I said, cross multiplication takes care of this. So if I cross multiply, it gives me this. C times cosine 23.5 equals 12 times 1. This one just has one extra step because now I need to divide by cosine of 23.5 to both sides. So once I divide that by 12 by that, I actually have the answer here. It works out to be 13.09 once I divide. Okay, so there's my answers. I've got a length for C, a length for A, and an angle for B here. Okay, that's what it means to solve a triangle. All right, your turn. Go ahead and try number 2. Okay, so first of all, we got to put things in the right spot. So if we're putting 36 degrees here, lowercase b needs to be across from there as an unknown, and they give us the hypotenuse. So here we go. Angle A, I want to start there with the easy one. We should get 54 degrees. All right, so it's kind of up to you what you started with. My work, I decided to start with side A, and then I'm going to use the hypotenuse. So again, I've got adjacent side, and the hypotenuse is given. That's the cosine relationship. So I set this up right here. Okay, multiply both sides by 9. Gives me this, 7.28. All right, again, I just kind of stuck with trig. If you want to use a decimal and Pythagorean theorem, you are allowed to. All right, that's obviously mathematically sound. Leg squared plus leg squared equals hypotenuse squared will work for B. I think this is cleaner and easier in my opinion. All right, so opposite over hypotenuse, multiply by 9, and we get there right away. Looks like I put the answer up here, 5.29. Okay, I'd like to just get by with just doing 3 and not 4 because there's going to be some overlap here in skills, but it starts off a little bit differently. All right, so what if they don't give us an angle right away? So here's a little diagram that you can write in. You can choose where you want to put 4 and 7. I just kind of put 4 on the shorter side and 7 on the longer side. Okay, so A is across from it. I don't know why I put 30 in there yet. Just wait. Okay, so now it's kind of up to you which angle you want to find, but we got to use inverse trig on this one, kind of like we did in 4.7. All right, so I'm going to start by finding A, but I could find angle B as well if I wanted to, but I decided to start with A. So tangent's the appropriate one to use because of the opposite and adjacent relationship here. All right, so this isn't like a special right triangle, 4/7. It's not like a square root of 3 over 2 or anything like that. So we're going to need our calculator if it's not one of the common angles. All right, so this is what we punch in our calculator. Okay, this happened again back in section 4.3, 4.4. Some of the applications, we had to go to our calculator and punch it in like this. So inverse tan, second tan of 4/7. All right, just so happens it was pretty close to one of our common angles, but it wasn't exactly. It was 29.7 degrees. So then just follow the directions. If they say nearest degree, fine, looks like I did. Or maybe they ask you to use some decimals here, okay? All right, so now that that's 30, you can throw it in your diagram so you can see what you got and what you're looking for. Now we're looking for angle B, so that's got to be 60 degrees now, or decimal form, right? 60.26. Okay, so we got 60 degrees here. And now we just got to find the hypotenuse. Since these are integers, it might be a good time to use Pythagorean's theorem. Looks like I just set up another trig ratio here. Sine of 30 equals 4 over c. Solve that and we get c. Okay? I have the comparisons here. One of them is 8.06, Pythagorean's theorem, or we could use that. I guess you pick which work you want to show. Okay, and there's one more example on the other side. Let's go ahead and do that now. This says, find the altitude of the isosceles triangle shown in the figure below, okay? This is something that you can count on for isosceles triangles. Maybe write this in off to the side. The altitude, which means the height from the base, serves as a perpendicular bisector. That's important to understand. Write it down, then I'll explain. All right, so it does just as it explains. If you drop that line down, you get a perpendicular line, meaning right angles, and it bisects this into two equal halves. If you want to write that in there, I put those like two little line segments to show that they are equal. Okay? All right, so for 5, the directions are here. Find the altitude. So we're looking for A. So here's the situation we have right now. Okay? They're giving us theta to be 35 degrees, this angle here, 35. And then the base is 12 all the way across. I'll give you a moment to pause and write that down. All right, we really just need one half of this triangle now because they're similar figures. So I took the highlighted triangle and kind of just went off to the side and did this. So this is 35 degrees. The height or altitude is what they're asking for, A. And remember, it's a bisector. So since B was 12 all the way across, we're going to take half of that for this side. Okay. All right, now we're just using our skills here again. Once again, how are these two sides related to that angle? Opposite and adjacent. So that's why we should use tangent 35. Equals A over 6. Multiply or cross multiply this. A times 1, 6 times tan 35, and that's what we get for our calculator answer. Okay? All right, so I'm going to take a couple minutes to do this. They go pretty quick because you only got one thing to find. Pause and try number 6. Okay, 28 degrees is our base angle. 7 is all the way across. 7's all the way across this base, so we got to bisect that and cut it in half, so we got 3.5 here. So this is kind of one of the triangles we need, and it's tangent again, 1.86. Okay, now also, in some of the problems you're going to do, angle of elevation, angle of depression come up. So just so I'm not going to take the time to kind of reteach that because we already did in 4.3. So I just want to mention this reference because when you flip the page in 4.3 notes, it goes over angle of elevation, depression again, followed by some problems and where we put those angles. So use that as a resource if you need a refresher on those terms, okay? All right, that's it for today.